Hello everyone, welcome to the Zoryar channel. What's the first thing that comes to mind when you hear the word laser? Is it laser cutting or laser beauty treatment? In fact, the core behind all of these is one thing: laser generator. Today, I'll break down all the key knowledge about laser sources in one go: working principle, functions, types, development history, and global brand rankings. Packed with practical insights, you'll understand everything instantly after watching. Let's first understand the core part: the working principle of a laser. A laser is simply a machine that generates laser light. It relies on the coordination of three core components: working medium such as optical fiber and crystal, pump source energy supply, and resonant cavity light focusing and amplification. Simply put, the pump source charges the working medium, enabling particles inside the medium to jump from a low energy level to a high energy level, forming population inversion. The resonant cavity then reflects and amplifies the light back and forth, finally emitting a monochromatic, directional, high-energy laser beam. This is the core logic of a laser. No complicated theories needed, just remember the process: charging, population inversion, amplification, laser emission. If you want an in-depth understanding of this principle, we have covered a detailed analysis in our previous videos. What exactly are lasers used for? You may be surprised to learn that they have long penetrated every aspect of our daily lives. Their core function is simple: to deliver energy with extreme precision. In industry, laser cutting, welding, and marking rely on its high energy density. It can cut metal and engrave chips with a precision of up to 0.01 millimeters. In medical treatment, laser eye correction and surgical cutting take advantage of its controllability, delivering minimally invasive and highly efficient results. In scientific research, laser ranging and nuclear fusion experiments depend on its high directionality, enabling it to accurately reach distant targets. Even everyday items like laser pointers and mobile phone facial recognition all rely on laser technology behind the scenes. There are four main types of mainstream lasers available today. First, fiber lasers. They are widely used in common laser cutting machines. Featuring compact size, high efficiency, and long service life, they are mainly applied in industrial processing and currently dominate the market. Second, co-lasers. They are primarily used for cutting non-metallic materials such as acrylic and fabric. With high cost performance, they are ideal for the advertising and textile industries. Third, solid-state lasers. They adopt crystals as the working medium. With highly concentrated energy, they are suitable for medical treatment, scientific research, and laser marking. Fourth, semiconductor lasers. They have the smallest size and low power consumption, commonly used in laser pointers, mobile phone sensors, and optical fiber communication. We come into contact with them every day. In addition, there are special types such as ultraviolet lasers and ultra-fast lasers, which are designed for ultra-precision microprocessing applications. From the laboratory to thousands of households, the development history of lasers spans just over 60 years, yet it has changed the world entirely. In 1916, Albert Einstein proposed the theory of stimulated radiation, laying the theoretical foundation for the invention of lasers. In 1960, American scientist Theodore Maiman developed the world's first UV laser, marking humanity's first access to controllable laser light. In 1961, China's first laser was developed at the Changchun Institute of Optics, Fine Mechanics, and Physics, keeping pace with global technological progress. In 1965, the co-laser was invented, kicking off the era of industrial laser applications. In 1990, IPC launched the first commercial fiber laser, bringing laser processing into ordinary factories. In 2013, the digital laser was created, opening a new chapter of intelligent laser technology. Up to the present, lasers have been evolving toward higher power, miniaturization, and greater precision. They are expanding into more high-end fields and becoming a core driving force for intelligent manufacturing. Finally, let's take a look at the 2026 Global Laser Brand Ranking. IPG USA, the pioneer of fiber lasers with top-tier technology and leading global market share. After 4 years of decline, it returned to full-year growth in 2025, achieving remarkable results through its diversification strategy. Trumpf, Germany, an industrial laser giant. It not only manufactures laser sources but also masters core light source technology for lithography machines, boasting solid overall strength. Lumentum USA, a leader in semiconductor lasers and telecom lasers. Most core components for smartphone facial recognition come from Lumentum. Raycus Laser China, A pioneer in China's fiber laser industry, it broke the import monopoly and stands out with excellent cost performance. Hans Laser China, China's leading laser equipment manufacturer with strong system integration capabilities, meeting full scenario application demands. Max Photonics China, it boasts self-developed technologies across the entire industrial chain, takes a leading position in ultra-high-power laser technology, and delivers top-tier stability and comprehensive strength. From theory to practice, and from the laboratory to industrial sites, every upgrade of laser technology drives the progress of science and technology. It serves as a precise scalpel, an efficient cutter, and even more a catalyst for future technological development. That's all for today's popular science about lasers. Zoryar, your reliable partner.